In the next few lessons, we are going to be looking at how to solve linear systems. Systems, meaning we're going to have more than one line. The first way we're going to look at how to solve them is by graphing the lines and see where they intersect. A system of linear equations is two equations that contain two variables and have line graphs. For example, this is a system, more than one line. A system. A system. And our goal in this lesson is to see what point or points these lines have in common, because that will be the solutions to these systems. The solution for the system is all ordered pairs that are solutions to both equations, meaning the x and y value has to work not only in one equation, but also has to be true in the other equation. The way we're going to find that today is by graphing it, and where the graphs intersect is the solution. We have three possibilities with lines. Lines can intersect at a single point, and that is going to be the solution. Or the lines are parallel and they never cross, and we would have no solution, meaning they have no points in common. Some books call this inconsistent. But I'm going to be fine with the words no solution, and that is because, again, the lines are parallel. Also, you could have one line on top of the other, and so they would coincide. So what would be the answer? Well, you would have infinitely many solutions. That's one way of writing the answer. Or another way would be all the points on the line. That's a solution. And some books call this dependent. I think I'm going to go with all the points on the line because I think that more accurately describes our solution set. So first of all, let's just go through and see if we have two lines and the given graphs, could we find the solution? Right, so I have graphed these two lines with a computer, and I can see that they intersect in that point. So what is my solution? Well, I have to tell you the ordered pair, the x and y coordinate of that point. And so what is it? It's over 2 and up 1. Remember, from the origin, we go, how do you get to that point? And you would go over 2 and up 1. So the ordered pair to that point is 2, 1. Now these two lines look parallel to me. And so what's our answer? No solution. And believe it or not, this line and this line are the same. Let's see why. If I divide all of that by 2, don't I get the same line? So my answer, again, you can choose, but I'm going to say all the points on the line. Again, infinitely many solutions because the lines coincide. Our job is to graph the line and then find the solution. So we have to go back and remember, how do we graph lines? We learn lots of different ways. We graph lines by plotting points. We graph lines by using their intercepts. We graph lines by using M and B. You can choose which way you want to graph the lines. I'm going to probably use the M and B method because I think it's the easiest. In fact, looking at number 1, I think it is going to be easy because both these lines are in that form y equals mx plus b. So let's look at line number 1. That's the slope. That's b. Remember, we plot b first, so on -1, and then we do our slope, rise over run. So I'm going to go down 1 and over 2. And remember how we did that to get a lot more points? I'm going to do that again. down 1 over 2, down 1 over 2. And I could do the opposite, up 1 over 2, up 1 over 2. Do you have to do that many points? No. And you've got to use a straight edge. And again, on my computer, that's very difficult for me to do. Okay, so that's the first line. Again, plotting as many points as you can, it's going to make it more accurate. Right now I'm going to look at this line. Again, the slope and the y-intercept. So my y-intercept is positive 1 and my slope is negative 1. So if my slope is negative 1, that's negative 1 over positive 1. So I'm going to go down 1 and over 1, down 1 and over 1, down 1, over 1, down 1, over 1. I'm kind of like a broken record. And when I do that, I can see that it intersected at that point. And maybe if you didn't graph enough points, you might not have gotten it. That's the bad thing about graphing. You have to be very, very accurate, right? So I haven't not finished. What's my answer? My answer is the coordinates for that point. So let's see, 1, 2, 3, 4, and down 1, 2, 3. How could I check that? I can check it by putting in 4 for x and see would that equal to 3. Negative 1/2 times 4 is negative 2 minus 1, is negative 3 because that's my y value. And if I put x as 4 there and I go negative 4 plus 1, is that negative 3? Yes. That is my solution because it works in both lines. Let's do that again. Take this line. I'm going to have m and b. b is at negative 2. My m is 2 over 1. Again, as many points as you can, and a straight edge will really help. All right, second answer. Second line, where's that b? Well, that's plus b, so b must be 0 because I don't see it, and m must be 1. So b is 0, m is 1 over 1. And look, if I do it this way, I know exactly where it crossed, right there. So that point is 2, 2. And again, you could check it by plugging it back in and saying, does 2 equal 2 times 2 minus 2? Yes. Check it in here. Does 2 equal to 2? Yes. So those two lines intersect at a single point. Now those were kind of easy because they were already solved for y. Let's look at these two. These are not solved for y. So again, I could use a table of values, intercepts, but I think I'm going to solve this for y. So I've given myself a little extra room here. So I'm going to subtract x. I'm going to divide by 2. I'm going to rearrange it. And remember, that's a 1. So my slope is negative 1/2 and my b is 6. Remember, we do b on the y axis, and then I'm going to go down 1 and over 2. Okay. Now I'm going to do this line and I'm going to do the same thing. So I'm going to subtract 3x, and I'm going to divide by negative 2, being very careful with those negatives. I'm going to rearrange. So my slope is 3/2, and b is negative 2. So up 3 over 2, up 3 over 2, ding, 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 ding. Those intersect right there. So what is that point? Remember, that's my answer. 1, 2, 3, 4, and up 1, 2, 3, 4. And how can we check it? We can put in 4 for x and 4 for y, see if that makes a true statement, and we'd have to check it into the other line as well. Okay, so let's look at number 4. I'm going to do the same thing. I'm going to solve for y. So I'm going to subtract 2. This time I'm going to write it as negative 2x plus 9 because I'm going to try to get that x first, right? So if I move that over there, it's going to be negative. Then I divide by a negative 3. Be careful of those signs. So m is 2/3 and b is negative 3. Again, check all those signs. Look at that arithmetic. So I have b is negative 3 and my slope is 2/3 up 2 over 3. Okay, now I'm going to take this next one and I'm going to move the 2x to the other side. I'm going to divide by negative 3, so that's going to be positive 2/3 plus 1. So my slope is 2/3 and b is 1. And I should know that if I have the same slope, what's going to happen? They're parallel. But I want to go ahead and graph it because the direction said to go ahead and graph it. So I'm going to graph this. But I already know what answer I have. These are parallel because they have the same slope. So what is my answer? No solution. And again, if you remember from way back, you could use that symbol for no solution. Let's look at these last two problems. Again, I'm going to take that and I'm going to solve for y. I'm moving the 2x to the other side by subtracting it or making it negative. And then I'm done. So my slope is negative 2 or negative 2 over 1 and b is 6. So b goes on the y-axis down 2 over 1. Try not to make your dots too big. Now I have y is equal to 4. This is great practice on remembering what kind of line is that. It's horizontal. So we have y is equal to 4. We know it's a horizontal line. Where do they intersect? Right there. And again, you could check those. So last one, I'm going to solve for y. So I'm going to move that x by subtracting it. I'm going to divide by positive 1. Oops, no, I'm going to divide by negative 1, and that's going to make all of those positive. So my slope is 1. There's a 1 in front of the x. And my b is positive 3. And then you know if I'm going to give you a horizontal line, I'm going to give you a vertical line. So we know this is vertical, x is negative 2, everywhere x is negative 2, you get a vertical line. Where they intersect is the answer. And again, if you check them, that works. So graphing is okay, but you have to be very careful, plot a lot of points, use a straight edge, don't make really big dots, and where they cross, that's your answer. Now if you notice, I did not do an example of where we're the same line. But if you have one in your classwork, which you probably will, Remember, you're going to end up with one line on top of the other, and you can answer at all points on the line. These are your three possibilities: 1 point, no solution, or all points on the line.